We continue Unit 5, Absolute Values. Now we write the equation for each of the following. So again, looking at that original parent function transformation, let me rewrite that for you. When we write the equation for each of the following, we do the same thing that we did in Unit 2, Transformations of Parent Functions. We do the same concept, except now we're just doing it with the absolute value. So starting with the absolute value of x, shifting up 3 is d. So this is plus d. Left 4 is c. And remember, this is opposite of the way we want. So we have plus 3 here and plus 4 here. So put this into the equation. Y equals the absolute value of x plus 4 and then the vertical movement of plus 3. Look at the next one. Reflect across the x-axis. That's out front because this is vertical reflection. Shift right 6 units. Shifting right 6 units is c. Remember, this is c, so it's going to be opposite of the way we think. So we are moving -6. Down 2 is vertical movement, subtracting 2. So this is d. Now that we have all of our pieces, let's put this into the equation. Y equals negative absolute value of x minus 6 minus 2. Let's look at the next equation. Reflecting across the x-axis, that's vertical movement. That goes out front. Stretch by a factor of 3. That is vertical movement, that is A. Shift left 4 units. That is x, and it is a liar, so we're adding 4. Down 1 is vertical movement, that is D. Let's put this into the equation. Reflect across the x-axis, goes out front. Y equals negative, stretch by a factor of 3, 3. Absolute value of x plus 4, and down 1. Let's look at the next equation. Y equals the absolute value of x. Shrink by a factor of 0.5. So this is vertical movement. So A is 0.5. Shift down 4 units is also vertical movement. That is D. Subtract 4. So writing the equation, y equals 0.5 times the absolute value of x and subtract 4. No right or left movement on this problem. Next example. Stretch by a factor of 2. This is our A. Right 3 is horizontal movement. This would be C, and it's going to be opposite of the way we think. So subtract 3. And down 6 is vertical movement. Subtract 6. That is D. So putting this into our equation, y equals 2 times the absolute value of x minus 3 minus 6. The last equation. Shift down 5. So this is D, subtract 5, and left 2. This is C, so add 2. Putting this into the equation, and we have y equals the absolute value of x plus 2 minus 5. So now we have just written the equation for each of the preceding absolute values. Now let's write the equation for the graphs pictured below. Notice this is the absolute value equation. So the equation, the parent function, is y equals the absolute value of x. That is given. What I need to look for first is, what do I notice? This particular graph is a reflection across the x-axis. So it is a vertical reflection. The next thing I notice is the slope is down 3 and over 3. Both directions. Down 3, over 3. Down 3, over 3. So the slope, or the vertical stretch, is 3 over 3, which is 1. Now I also notice that the graph moved up 1, 2, 3 spaces. So it's vertical movement up 3 units. Another way to look at that is the original parent function starts at 0, 0. It moves over to the left so many units and moves up 3. This is the new point. So we know it moved up 3 units. Because it moves to the left 6 units, then in the equation I want to remember that this is the C. Because we're going left 6 units, that is our C. So we want to remember to put a plus 6 into the equation because our horizontal is a liar. So we need to remember that. Horizontals are opposite of what we think they're going to be. Let's write that equation. Y equals, this is important, don't forget the y equals. Y equals the absolute value of x. Let's finish writing this up. It is a reflection across the x-axis, so it's vertical movement. The slope is 1. We're going up 3 units, and we're moving to the left 6. I do not have to have the 1 written in the equation. Let's look at the very last one. The original parent function starts at the origin. There is no reflection. It moved left 1 unit. So this is our C. It moves left 1 unit. So that is our C. So since it moved left, we're going to say positive 1. And it moves down 2 units. The slope, starting from the new point, is up 2 over 1. Both sides of the graph, up 2 over 1. So the slope is 2 over 1, which is 2. Let's put this into the equation. Y equals, don't forget the y equals, that's important. 2 over 1, which is 2, times the absolute value of x, plus 1, because it moves to the left 1 unit, minus 2. So we have a vertical stretch of 2 units, which is our slope. We moved left 1 unit, so we add 1 inside the function, and down 2 units. This concludes day 2 of your foldable.